For centuries, scientists all over the world have been working hard to understand how the Earth was formed and how we all came into existence. But having only one example makes it difficult to find answers. So scientists are turning to other planets like Mars to look for traces of early life. Since the first telescope observations of Mars in the 17th century, we have suspected that Mars is more Earth-like than any other planet. Millions of years ago, these two planets may have shared the same primitive environments. So if life existed on Earth, it could also have developed on Mars. To prove this hypothesis, the future ExoMars mission will drill up to 2 meters into the Martian soil, with the hope to find past or present bacteria-like life forms which may be buried deep underground.
We will be able to sample material from below the surface. That is quite important to understand if there is any sign of past life activity on Mars.
But some of the clues to life on Mars may be hidden in the red waters of the Rio Tinto in the south of Spain. In Rio Tinto, you find bacteria which can live in extreme conditions. This is why they are called extremophiles. The extreme conditions faced by these bacteria are very acid waters. The main characteristic of these bacteria is not only that they can live in acid waters, but that they themselves create this acidity. These are the bacteria scientists are looking for on Mars, and they have been studied in the Spanish Astrobiology Center near Madrid, a world reference when it comes to the study of carbon-based life. The Astrobiology Center was created with the wider goal of discovering the origins of life. What we want to do is to dig deeper in the areas where the disciplines cross over and where there is a lot of research to do. We have astrophysicists who look at the universe. We have planetarian geologists who study the bodies of our solar system, and we have prebiotic chemists who try to understand the chemistry which preceded life itself. Tapping into the chemistry before life appeared is one of the objectives of the Cassini-Huygens mission to Titan, the largest moon of Saturn. Following its landing on the surface in 2005, the Huygens probe has been sending valuable information on the composition of its surface and atmosphere. There are very strong similarities between primitive Earth and Titan. Its carbon chemistry is very evolved. The only difference is the absence of liquid water on a permanent basis. So, finding out what's happening on Titan and understanding this chemistry will help us better understand what happened on Earth some 4 billion years ago, as there is no longer any trace of that today. But did life on our planet appear through pure chemistry, or was it brought to Earth with the help of comet seeding? Rosetta, the European Space Agency's mission to comet Churyumov-Gerasimenko, may help us to find some answers to this fundamental question. Reaching its destination in 2014, it will drop off a small lander with a big mission to look for organic molecules hinting at early signs of life in the comet's mysterious core. Life-searching missions are also planned on other celestial bodies, including Saturn's magnificent moon Enceladus and one of Jupiter's icy moons Europa, both of which harbor water, one of the conditions for life to form. However, the search does not stop there.
At the end, we don't look for life, we look for habitable zones. That means to look for places where all these elements are together in an environment that is compatible with the capability to develop life. That's why nowadays the research of these worlds is not limited only to our solar system, but it goes beyond, and we have to look for external solar system, for other moons, other planets around stars.
Finding traces of life elsewhere in the solar system will help us understand better where we come from and where we may go to. But it can also help us identify potential future homes for mankind outside planet Earth.